Okay, hi guys. This will be my presentation on my women's hockey visualization project. So before we get started with the actual visualization, I want to talk just a little bit about the goals and the data. So let's just get started. So one of the purposes of this project was to myself learn some things to do in Power BI, learn how to build things, learn how to use the Power BI tool. I'm still relatively new to Power BI. I've just worked on it for maybe 5-6 months. So I'm still learning as I go. So one of the purposes of this project is simply to learn how to do things in Power BI. Now, another purpose, another goal is for others to also learn from this. So I want to show others how to build things in Power BI. I want to help others get started with doing hockey analytics in Power BI. Now, I just talked to a Swede earlier today that's actually doing hockey analytics in Power BI. So that means we're now two guys. Other than him, I've literally not met anyone else doing hockey analytics in Power BI. So it is a very underutilized tool, but I think there are some cool features. And once you get the hang of it, it is a pretty powerful tool, especially when you want to visualize a very, very large data set. So those are the two first goals. Learn how to do things in Power BI and teach others how to do things in Power BI. Now, the third goal is perhaps the most important one. And I think this is really important to understand. Now, I'm very, very purposely in these visualizations working with a very broad vision. I'm not trying to focus on one specific area of the game. I'm literally trying to fit in as much information as humanly possible into these visualizations. And that in itself is the functionality of these visualizations. So why am I doing that? I want to build a visualization that has a functionality for me as a coach, or for me as a media person, or for me as a scout. And to do that, I don't want to limit the possibilities in any way. So I'm trying to do visualizations where you can look up literally anything from the entire data set in just these few visualizations. Now, to do that, I have to build visualizations in layers upon layers upon layers upon layers, because that's the only way you can fit everything into just a few visualizations like this. But the entire point is that I'm not trying to direct you in any specific direction. I'm trying to leave it up to the user what they want to look up. And then I'm giving them the option to look up that very specific thing. And that is the functionality of the visualizations in itself. So in order to use this properly, you need to know what data, what information you want to extract from the visualizations. You also need to know where you can find that data, and you need to know how to interpret that information. Those are the three things, but those things are left up to the user himself. But once you understand that, and once you understand that you can look up literally anything from the entire data set within these few visualizations, then the possibilities are almost unlimited. If you want to know the average shot distance for Kendall Coyne Schofield, you can just go look it up. If you want to know on the power play, what is the shot distance, you just go look it up. If you want to know the total possession time in the offensive zone, by Amanda Kessel. Just go look it up. You can find the data within the visualizations. But it's up to the user to know what to look for. So this is something that I'm doing very purposely, because this is what I would want as a coach, as a media person, as a user of the visualization tool. This is what I would want. I don't want to be limited in any way. I want to be able to look up everything. And that in itself is the entire purpose of these visualizations. So the final goal is to build something that is unique, something that is distinctive. This is something I always try to do. I don't really want to duplicate what someone else is doing. I always want to do my own thing. And simply working in Power BI means that my visualizations, just by that fact, is almost always quite distinctive, because no one else except one suite is actually doing hockey analytics in Power BI. So those are the goals, I think. Now, obviously, this means that in these visualizations, I'm not doing any attempt to model the data. I'm not trying to build a game score model. I'm not trying to project future performances. I'm not modeling the data in any way. This is not the purpose of this specific visualization project. It's also important to understand that I'm not necessarily trying to interpret the data. It's up to the user themselves to know what data to look for, know where to find the data, and know how to interpret the data. So I'm not trying to lead you in any direction, but that in itself is the purpose of these visualizations. So I hope that makes sense. Now, next step is we'll talk just a little bit about the data, because there are some important features that we need to discuss. So first of all, the data set from SportLogic consists of, there are two different models describing expected goals. In the data, you have an all attempt model, you have an shot on net or an on net XG model. So you have two distinct models describing expected goals. Now this makes a lot of sense, because when you want to use the XG model to describe play driving, when you want to describe shooting, you absolutely want to use the all attempt model, because you want to credit or discredit the shooter with the shot block. If you, as a shooter, shooting into a block, then it's up to you. Then it's your fault. If you're missing the net, then it's your fault. On the other hand, when we're modeling goaltending, when we're looking at goaltenders, we don't want to credit the goaltenders with shots that misses the net. We don't want to credit goaltenders where the shot is blocked. That's not something the goaltender has any effect on. So when it comes to describing or modeling goaltending, you want to use the shot on net model. Now, there are just one problem with the data, and that is that in the play-by-play data, you don't have the shot on net model. So this means that in the goaltender visualizations, there are some expected goals data. There are some goals saved above expected data that I cannot, where I cannot use the shot on net data, simply because I have to extract that GSAX number, have to extract that XG number from the play-by-play data. So this is specifically when I'm looking at shot aim. But I will try and discuss it very shortly when I'm going through the visualizations as well. So that's just one important thing take note of. Now, the other thing is that the play-by-play data in this dataset does not contain any information about who's on the ice at the time. So all on-ice information that we got, we have to take from the summary data. Now, this is a little bit problematic because the summary data does not include all the on-ice information that I would want to have included. But there's nothing we can do about it. So, for instance, if I wanted to look up plus minus for a player, it's simply not possible using the sport logic data because there's no way to know how many goals for and how many goals against any certain player has been on ice for. That information cannot be found anywhere within this dataset. I'm not saying you should look up plus minus, but if you wanted to, it's not possible. You have to look it up somewhere else. And that's just one of the limits with this dataset. It would be super, super cool if we had on-ice information directly in the play-by-play data, but because this would allow us to look up on-ice possession time, for instance. But that's not something we can do, and there's nothing to do about it, really. So with that, we'll go on to discuss the actual project. So basically, the visualizations themselves, that's 3 dashboards put together into one visualization. So you have a skater dashboard, a goaltender dashboard, and a game report dashboard. Besides from that, we also have a few video tutorials, some how to build things in Power BI. This goes back to the second goal of this list. We want to show others how to build things in Power BI. So you can find a few video tutorials on YouTube or on my website. I'll go there in just a minute. Now, the final part of this visualization project is my women's hockey workshop on Power BI this upcoming Saturday, July 15th at 12:30 p.m. Eastern Time. I will have a short workshop on how you can build things in Power BI. So let's just go to my website. Just click on this link. And on my website, hockey-statistics.com, you can find an article where I'm talking about the visualization project. Now, I don't want to talk about this article really, but I just want to show you can find the videos here. But other than that, I don't really want to discuss it right now. So you just want to click on the actual visualization. There's a light version and there's a dark version. So we'll just go to the dark version here. Okay, so this is what the skater dashboard looks like. So we just want to use an example. We can go to Marie Philip Poulin, just like that. And from here, we can extract almost any information from the entire data set in this one single visualization. So we'll just go through it really quickly. So in the top bar up here, we have information about the player, the team, the position, and then we have how many games has she played. The blue donut chart here shows how many games has she played out of a total of 20 games. So you can see she has played all 20 games. Now, all other donut charts, all other metrics you see indicate the ranking among other forwards. So you can see that Poland has 12 goals. That means she's ranked number 1 among forwards. She has 9 primary assists and 6 secondary assists. So she's probably ranked 3rd or 4th in primary assist and 2nd or 3rd or something like that in secondary assists. Okay. That's how you interpret the top part of the visualization. So I selected Poland because she's an interesting player. She's obviously very, very good. But if we go to player tables here, we get to see information about the entire league at once, all the players at once. So the one that sets Poland aside from all other players is her number of completed passes. So every single 60 minutes of even strength time, she has 100.7 pass completions. That is almost 30 more than the number 2 on the list. So this is something where she really stands out from everyone else. She's completing more than 100 passes every time she plays 60 minutes of even strength time. So this is interesting. She's also near the top in all the other metrics here. This is possession time per 60 minutes. So every time she plays 60 minutes of even strength time, she possesses the puck 7.36 minutes of those 60 minutes. And in the more classical expected goals for percentage, she's also near the top. She's at 66.61%. But anyway, we want to dig a bit deeper. So we'll just go to statistics and go to the passing stats here. So when we do this, we can see her passing data in much greater detail. So we'll just look at even strength data here. So when we do this, we can see that she has the 100.7 passes per 60 minutes, but she's also leading the league in defensive zone completed passes, neutral zone completed passes, and offensive zone completed passes. She's literally ranked number 1 in all of those categories. Her passing distance is 32.7 yards on average, which is not long passes, not short passes. It's right in the middle, more or less. She does have a pretty large amount of incomplete passes per 60 minutes, but when she's doing this many passes, it's not really surprising in any way. In terms of slot pass completions and scoring chances generated, that data is not possible for even strength. We only have that data for all strengths. So if we go to all strengths, we will see that she's also ranked number 1 in those 2 metrics. So that's the passing data. You could look up anything else, really. But we'll just focus on the shot data instead. So we can go to shot plot, and here we can see all her shots. The pink ones are goals, and you can actually hover over and you can see data for that specific goal. Now, the interesting part is looking at her shot aim. So you can see that Poland has 12 goals, but 10 of them are in the top left corner or in the top right corner. So she's definitely scoring most of her goals in the top part of the net. Now, just one comment on this. The coloring, the background coloring is based on a delta value that I have calculated. So this is basically delta individual goals per minute equals 0.011. So what does this mean? So this means that for every minute of ice time, Poland is scoring 0.011 more goal than the average forward in the top left corner. So this may sound like a small number, but that's actually a really high number, which is why it's very blue. Now, if it's red, it means there's a negative value, so she's scoring less than the average forward per minute. But since she doesn't have a goal in the bottom right corner, she's obviously scoring less than the average goaltender. No one has scored any goals in the crest area, by the way. So this field will just be left white in all of the, no matter what player you're looking at. Okay, so this was the individual goals. You could also look at goals scored above expected. Still, blue means better than average, red means worse than average. So here you can see a clear trend. Poland is having a huge success shooting high up in the net, but she's actually quite poor when it comes to scoring low in the net. This is an interesting thing to take note of, I guess. Now, you can also select a specific shot type. So if we select slap shots, it will show all of slap shots, and it will show the data just for slap shots. She's not really a slap shooter, so there's not a lot of data here. But this is how you can look up the data. Okay, that was the shooting part. You can click on this link and it will go to the WHKYHAC player page. Okay, so the final thing I just want to talk about in the skater visualization is the radar chart. So I've selected 8 categories that I find interesting, that kind of summarizes the quality of the player. So this is expected goals for percentage at even strength. This at all strengths, I think. It will change when you change the strength state. I've selected the goals per 60, primary assist per 60, secondary assist per 60, completed passes per 60. This was the one where she has 100 and some passes, leading clearly. The radar chart works like this. So it indicates her ranking within this specific category. So if she's all the way to the top, means she's ranked number 1. So you can even go here. So you can see there are 45 players meeting this meeting the minimum time on ice requirement. And she's ranked 43rd, so this means she's ranked number 3. She's ranked 3rd in primary assists. So that's how you interpret the radar chart. Now, you can also look up possession time per 60 minutes. This is how much is the specific player possessing the puck per 60 minutes. You can look up zone exits, zone entries per 60. Okay. And as you can see here, she's actually ranked top 5 in every single category. So it's fair to say that Marie-Philip Poulin is a halfway decent hockey player. Sorry. So that's it. I don't want to talk more about the skater viz. We'll just go on to talk about the goaltender viz. And here it is. You can use this in the same manner as the previous visualization, and look at one specific player. But instead of doing that, I want to look at the all players functionality. So now we're looking at all players at the same time. So this is an interesting thing you can do in order to get proper context. So we can see here that the average save percentage for all the goaltenders is 92.3%. That's actually very, very high if you compare it to NHL data, for instance. You also see that the GSAX, goals saved above expected, using the on-net model is 44.17. And the data set is just around 40 games. So on average, the goaltenders are saving more than a goal above expected each and every game. So this would indicate that the goaltenders have been dominating this season, and or the GSA, the XG model is perhaps not calibrated correctly. You like the total GSAX to be at least close to 0. In this case, it's way above. But this is just something that you need to understand. So when you see someone having a GSAX of 0, a goaltender with a GSAX of 0, it doesn't mean that she's average. It actually means that she's well below average. So that's just an important context to be aware of. Now, per default, I've just let all the donut charts be fully blue when you're looking at all goaltenders at once. So that's just how it's defined. Now, you can look up specific statistics. The average inner slot save percentage for all the goaltenders, the screened save percentage, the slot save percentage, and so on. Now, what is more interesting is perhaps looking at the shot aim visualization here in the middle. We should clearly see right away that most goals are being scored in the top left corner and top right corner, and not so many goals in the bottom part of the net, and 0 goals in the crest area. So this would indicate one of two things. Either the skaters are just shooting way more in the top part of the net, or goaltenders are letting in more goals in the top part of the net. That's the two options you got. So if we look at the expected goals against data, we actually see that skaters are not shooting at the top part of the net. They're actually shooting more in the bottom part. So this would mean that a shot in the top left corner or top right corner has a much higher chance of going in than a shot in the bottom left corner or bottom right corner, because shooters are shooting more at the bottom of the net, but they're scoring way more on the top of the net. So this we should be able to see in the save percentage. So in the top left corner and the top right corner, the save percentage is only around 86-87%. In the bottom right corner, bottom left corner, the save percentage is close to 95%. So there's a huge difference. So this is something that is interesting to look at, and this is how you can use the all functionality of the visualization. So I don't think I want to talk more about the goaltender viz. We'll just go to the game report and talk really quickly about that one. So this is what it looks like. So in this report, you can look up a specific game and you'll find data for that specific game. Now, if I had to redo this one, I would probably do it slightly different, but it works as it is. So you can select the date, and then you can select the game, and then you have data for that game. And you can elect to look at even strength, power play, shorthanded, or all strength. So if you click on this one, we're looking at all strength, and we can see that the data changed slightly. If we want to see where is the goals being scored, we just click on goal, and it filters the shot plot. This filter only filters the shot plot, by the way. We have a lot of information on the left side, the away team, and on the right side, the home team. I don't want to go into details about these. You can look into it yourself, and there's a short explanation above. The graph at the bottom is I don't know what to call it. It's a race plot, I guess. So you could look at the classical one is the XG race. So how is the XG how's the running total of the XG as a function of game time. So you can see here at 11.12 minutes into the game, Harvey's has a total of 1.32 expected goals, and so on and so on. So it's just a raise of how is the XG going as a function of the game time. That was the word I was looking for. Now, the interesting thing, this is a very classic plot, but you can, with this data, you can also look at pass completions as a function of game time, or you can look at total possession time as a function of game time. So here you can see that after 60 minutes of ice time, Sonnet team has possessed the puck for 31.57 minutes of the game. And Harvey's has possessed the puck of 23.5 minutes of the game. So there is a small amount of minutes that are not accounted for when no team in the data set are possessing the puck as per the data. That's just what it says. But on average, teams possess the puck around 55, 56, 57 minutes per game. And the final thing you can look up is the offensive zone possession time as a function of game time. So I think that's it. I don't think I want to talk more about the visualizations. I hope you enjoyed the video, and I hope you will use these visualizations. I think they're pretty cool. And I'll add a link under the YouTube video with the visualization and with the link to my website, the visualization project article. So that's it from now. Goodbye.